7.5 to 7.8 quiz. All right, so first thing we're doing is we are finding a plus b for this given vector a and vector b. All right, so simply to find a plus b, we add the different corresponding components of the vector. So 7 plus 10 is 17. 3 plus negative 20 is negative 17. Negative 1 plus 4 is 3. And 5 plus negative 3 is 2. So that's a plus b. Okay, now we can do a minus b. So we're doing the same exact thing, but we are subtracting b this time. So we do 7 minus 10, which is negative 3. Negative 1 minus 4, which is negative 5. 3 minus negative 20. Remember, 3 minus negative 20 turns into positive 20, so it'll be 23. And then 5 minus negative 3. 5 minus negative 3. 5 plus 3, which is 8. So that's a minus b. Negative 3, 23, negative 5, 8. Okay, go another color. All right, now we'll do 2a. 2a is simply taking matrix A and multiplying 2 into every part of it, every element. So 2 times 7 is 14. 2 times 3 is 6. 2 times negative 1 is negative 2. And 2 times 5 is 10. So that's 2a. All right. Now lastly, we have a plus 3b. All right, so we're going to take matrix A and we're going to add it to matrix 3b. So I'm just clearing out matrix A here a little bit. So first we need to know what matrix 3b is. So 3b is simply 3 times matrix B here. So that'll be 3 times 10, which is 30. We got 3 times 4, which is 12. We got 3 times negative 20, which is negative 60. And 3 times negative 3, which is negative 9. So that's 3b. All right, so we're doing a plus 3b again. I'm just going to recopy matrix A right over here. So matrix A is 7, negative 1, 3, and 5. So we're taking matrix A and we are adding 3b to it. So a plus 3b a plus 3b. It's going to be another 2 by 2. So we take the first one in each row 1, column 1. So 7 plus this 3b here, which is 37. 7 plus 30. We got negative 1 plus 12, which is 11. 5 plus negative 9, which is negative 4. And 3 plus negative 60, which is negative 57. So those are our 4 answers to this first problem, number 1. All right, on to number 2. All right, so for number 2, we are finding a times b. And remember, we do rows by columns, and we write rows by columns again for both of these. And remember, these two numbers have to be the same. So this is a 3 rows by 2 columns. This is a 3 by 2. And this other one is 2 rows by 3 columns. So it's 2 by 3. So we know this is even possible to do at all because these two numbers, the 2's, are equal. Those two numbers are equal. So that has to be true for us to be able to multiply at all. So that's true. And then we know our solution matrix is going to be a 3 by 3. It's going to be a 3 by 3. The remaining numbers tell us what it is. So we need a 3 by 3. So 3 by 3. We make a huge 3 by 3 over here. All right. So we need 1, 2, 3, 1, 2, 3, 1, 2, 3. I'm going to write it a little smaller over here for us to simplify it. All right. So here we go. So the first thing we do is take when we multiply matrices, we have row 1, column 1. We take the row 1 of our first matrix and multiply it by column 1 of our second matrix. So row 1 times column 1. row 1 times column 1. So it's 1 times 6, 1 times 6 plus negative 2 times 4. So that's 6 plus negative 8, which is negative 2. So that's the simplification of it. Okay. Next, we take, so for row 1, column 2 here, we take row 1 and we multiply by column 2. So row 1 times column 2. So I got 1 times 2 plus negative 2 times 0. That's 0, that's 2, so this is just 2 right here. All right, finally, for my row 1, column 3 spot, I take row 1 and multiply by column 3. So 1 times negative 8 plus negative 2 times 0. So that's 0, that's negative 8, so our answer is just negative 8. So that's our whole entire row 1 of our solution matrix. I'll change colors and we'll do it again. All right, so now I'm going to do row 2 to fill out my entirety of row 2 here. And I take row 2 and multiply by column 1, 5 times 6 plus 4 times 4. That is 30. Come on, don't quit on me now, computer. So we've got 30 plus 30 plus 16, 30 plus 16, which is 46. Okay, then for our next one, we take row 2 times column 2. So we're going to take our row 2 of this first matrix and multiply by column 2 of the second. So we've got 5 times 2 plus, so that's 5 times 2, plus 4 times 0. That's just 10 plus 0, which is 10. Okay, then finally I take my row 2 times column 3 here, 5 times negative 8, plus 4 times 0. So 4 times 0 is 0, 5 times negative 8 is negative 40. All right. Finally, for my row 3 here, my solution matrix, I take my row 3 and multiply by column 1 for this first one. So row 3 times column 1, I've got 6 times 6 plus 0 times 4. So that's just 36. Take this row 3 times column 2 for this second spot. So I got 6 times 2 plus 0 times 0. This is going to be 12. And then finally, for this row 3, column 3, I take my row 3 and multiply by column 3. 6 times negative 8 plus 0 times 0, which is negative 48. And this right here is the solution, the final answer to this problem. AB equals this right here. Okay, moving right along. Find the determinant of the following matrices using the lattice method. The lattice method. This is by hand, by hand. Okay, so our first step when we're using this lattice method to find the determinant, again, the determinant, if this were called matrix A, the determinant is, it looks like the absolute value bar. So we're finding the determinant of A, if this were A. So the first thing we have to do is copy these first 2 rows again. So 2, negative 1, 2, 0, 1, 2. All right, copied the first 2 rows. Now, I make my, oh, didn't want to change all the colors of that. Hold on. There we go. All right, so I make my diagonals. So I'm going to have 3 diagonals. 1, 2, and 3. So I'm going to find the product of those 3 diagonals, and those are the ones I'm going to add. So I'm going to do 2 times 1 times 1 plus 0 times 1 times 2 plus 3 times negative 1 times 2. So those are those three that I'm all adding. I'm just circling them to indicate they're coming from each of those circled diagonals. Okay, so that's 2 plus 0 plus negative 6, which is negative 4 altogether. Okay, and now I'm going to subtract the product of the green diagonals. So there's the first green diagonal, second green diagonal, third green diagonal. So those three diagonals I'm going to all subtract. So we're going to subtract 2 times 1 times 3, and we're going to subtract again 2 times 1 times 2. We're going to subtract again 1 times negative 1 times 0. And again, I'm just going to circle all those just to indicate where they're coming from. And we're subtracting all of them. All right, so that's minus 6, minus 4, minus 0. That's minus 10. Negative 4 minus 10 ends up being negative 14. So that is the correct answer for our determinant of this first A. I'm going to do the same thing for this one over here, for B. All right, so again, we copy first. So copy the first two. So 1, 3, 2, 0, 5, negative 5. Okay. So given that this one has lots of zeros, it should be a bit easier. So here we go. There's our first diagonal, second diagonal, third diagonal. And these are all red. They're all downward sloping. These are the positive ones. So I've got 1 times 5 times 0 plus 0 times 0 times 2 plus 0 times 3 times negative 5. All right, notice how they all include a 0. So that's just going to be 0 plus 0 plus 0, which is 0. All right, now I got to do the subtracted ones. All right, first diagonal, second diagonal, and third diagonal. I'm subtracting the product of each of those trio of numbers. So I've got minus 2 times 5 times 0, minus negative 5 times 0 times 0. Let's put that in parentheses so it's not get confused. Minus one more, 0 times 3 times 0. Again, they're all 0. So 0 minus 0 plus 0, anything with zeros is 0. So the determinant of that matrix is 0. All right, number 5 and 6, we're finding the inverse of the following matrices. For number 5, we're finding it by hand, and for number 6, we're using our calculator. So let me go ahead and launch this calculator. So we are up, it's already all set, so we're good to go. All right, so we are finding the inverse. This purple color, we'll go with that. All right, so finding the inverse. So how do we find the inverse of a matrix? Well, if this were matrix A, the way that we would find the inverse is the following formula. A inverse equals 1 over the determinant of A times the rearranged version of A. So if A were the 2 by 2 in the arrangement A, B, C, D, like so, then A inverse would be 1 over the determinant of A times the rearranged version of these cells. So the A and the D switch, so D goes in the top left and A goes in the bottom right. This is freaking out. Hold on. So D goes in the top left, A goes in the bottom right. And then B and C just get negated. You don't move them. So it's negative B and negative C. All right, so that's what it looks like. So that's our formula. So now we have to apply this formula. So the first step is finding the determinant, finding this A with the bars around, which means the determinant. So the determinant of A is, we do 6 times 4 minus the sum of negative 5 and negative 5. Sorry, not sum. Product. Negative 5 times negative 5. All right, so we've got 24 minus, that's 25. So negative 1 is our determinant. So that is the determinant of A. All right, so that's negative 1. So that's the number that's going to go into here. So I've got 1 over negative 1 times this following matrix. So I swap the A and the D. So I swap 6 and 4. So it becomes 4 and 6 instead of 6 and 4. All right, and then these both get negated. So if they're already negative, I make them positive. So positive 5, positive 5. All right, so the inverse of this is just 1 over negative 1 times this. Well, 1 over negative 1 is negative 1. So I multiply negative 1 into all these, and they just all get negated. Negative 4, negative 5, negative 5, negative 6. And that's the inverse of this given matrix right here. And there we go. All right. Okay, for number 6, we use our calculator. So we're going to enter this matrix into our calculator, and we are going to use the calculator to find the matrix. So let's get it. So we go to second matrix. We enter this into our calculator. We're going to edit. It's already a 3 by 3, which is what we want. All right. So for the first one, we want 2, 0, 3, 1, 1, 1. So 2, 0, 3, and then 1, 1, 1. And then for the other two, the last row, 2, negative 2, 1. 2, negative 2, 1. Let's go back to that. 2, negative 2, 1. All right, so that's our matrix, 2, 0, 3, 1, 1, 1. 2, negative 2, 1, and it's our matrix A. So we just got to remember that because that's the matrix we want to find the inverse of. So we go to second matrix, we click the name matrix A, and we want the inverse, which is this button right here, X the negative first. So A inverse, enter, and there is our matrix. So we have negative 1/2, negative 0.16, negative 2. So these are, if you know the fractions of these, that is possibly of help to you. So we've got, I'm just going to screenshot this. And we'll paste it in there for our solution. So here we go, inserting in our solution. All right, it's a little large. So there's the first part of it, and then here comes the second part of it. So there we go. So there's our solution there. So we have negative 1/2, negative 0.16, 0.66, 1, 0.66, negative 0.66, 0.5, negative 0.16, and negative 0.33. You put the fraction versions of those, that'd be fine too. All right. Next, on to number 7. Okay. All right, we're going to do number 7 in a part 2.